Okay, circuits. First question, we've got this set up here. 2 terminals and 3 batteries connected in series like that. Each battery is 1.5 volts. And you have to pick the correct diagram from the answer sheet. How do you connect these batteries when they're drawn like that, such that the output across here will be 4.5 volts? Well, I'll use that one. If you connect the first one like that, it's trying to push current out in that direction, conventional current. If you connect this one the same way, it's also trying to push current in the same direction. And if you connect this one facing the same way, that is facing the same way because the direction of the wire has changed. Then, because all 3 are facing in the same direction, their voltage will add up, and that will give you the 4.5 volts. 1.5 plus 1.5 plus 1.5. That is the same as this. 3 cells in series like that. Those 2 are identical. It's just that in this one they've just bent this wire round. And as you know, when you connect 3 cells in series to create a battery like that, you just add up their voltages. So 1.5 plus 1.5 plus 1.5, that will give you the 4.5 volts across there. Okay, moving on. Right, we have this circuit here. I've got a variable resistor and a resistor R. We connected a voltmeter, we've connected a voltmeter across the variable resistor to measure that voltage, which is called V1, and another voltmeter is measuring V2. You always connect voltmeters in series with the thing that you're measuring the voltage across. Okay, and I want to know how you connect an ammeter to measure the current in this circuit. So some current, I, is flowing. It's a series circuit. No current is flowing through the voltmeters because the resistance of a voltmeter is infinite. So the only current is flowing like so. Okay? It's the same current all the way around because it's a series circuit. How do you connect an ammeter? Well, you always connect ammeters in series because their resistance is 0. So you could connect it there and draw a capital A in the circle. That'll get you the marks. You could connect it there if you wanted, or even there. Yeah. Don't draw it there though between the 2 things. Just draw it there or there. Okay. Right, what's this? Yeah, they've given us this voltage resistance. So resistance in ohms, voltage in volts, between 0 and 10 volts. This is between 200 and 600 ohms. Okay, now V2 drops from 9 to 6. Okay, 6 volts here at 600, right? So we've got 9 volts there, and this one goes from 3 up to 6. Okay, so V2 drops from 9 to 6, from 200 to 600 ohms, and V1 goes from 3 to 6 like that. That's V1, and that's V2. Okay, so what they're doing is changing the resistance of the variable resistor between 200 and 600 ohms, and it's affecting the voltages across each of them like so. Right, from this you have to say what the voltage provided by the battery is. Okay, well, whatever voltage is between, I'll do some different colour. Whatever voltage is between that point there and that point there, that's the voltage provided by the battery. Okay? And because that's directly connected to this point here, and directly connected to this point here, it's also equal to whatever the voltage is across both of the components. Which is probably an overcomplicated way of saying the voltage provided by the battery is put across all the components in the circuit. It's sort of kind of obvious. Anyway, if you look here, at 200 ohms, when the resistance of the variable resistor is 200 ohms, the voltage across V1 is 3. Okay, so that's 3 volts. And the voltage across V2 is 9 volts. Right? Which means there's a 3 volt drop across that, and there's a 9 volt drop across that. And that covers all the components in the circuit. And therefore the total voltage drop is 12 volts. And therefore the voltage between that point and that point is 12 volts. The total voltage drop, and therefore the voltage across the battery is 12 volts. So the battery is providing 12 volts. That's the answer. So it's 3 plus 9 is 12. That's how you would work out the voltage provided by the battery just from this. Okay. What's the resistance of R? Right, again, we have to work out the resistance of R just from this. Well, slightly tricky, but no problem. Look at this point here. When this resistance is 600 ohms, the voltage, I'll do some green, no, this will do. Okay, at this point here, this voltage V1 is 6 volts, okay? And the same V2, okay, it's also 6 volts. So, when the resistance of these two components is the same, the voltage drop across them must be the same. Because in a series circuit, the voltage drop across any component is proportional to the resistance of that component. So, because they're both dropping 6 volts across them, they must therefore have exactly the same resistance at that point. And the resistance is 600 ohms. Okay, so therefore both 600 ohms at that point. So therefore R is 600 ohms. It always has been, because it's not variable, it's fixed at 600 ohms. Okay. Okay, you have to give a reason. Well, it's what I just said. Because they have the same voltage across them at that point, they must therefore have the same resistance. And that means the resistance of both is the resistance is 600 ohms. And because that's not variable, it's always 600 ohms. Okay. Right, we've got to work out the current I when the resistance, the variable resistor, is 200 ohms. Okay, so we're back to this point here. So let's write in 200 ohms here. That's now 200 ohms. That's always 600 ohms. Okay, so we're dealing with these numbers, 200 ohms there, 600 ohms there. Voltage across V1 is 3, so we're back to that voltage, and voltage across V2 is 9. So those are our numbers in pink. We have to work out I. Well, V is IR. Classic equation. I hope you know this. If you don't know it, commit it to memory now. Voltage is current times resistance. Okay? So we want to work out I, so rearrange it, divide both sides by R to make I the subject, and you get I is V over R. So, like I said earlier, the current at every point is the same because it's a series circuit. So we can look at either of these to work this out. Because look, the current going in and going out of there is the same as the current going in and going out of there. So let's do this one, why not? So the current is the voltage across it, 3 volts, over the resistance, 200 ohms. Okay, and that turns out to be 0.015 amps. Unit of current is amps. That's it. Pretty straightforward. And to prove to you that we could have used either, let's do the same calculation using this one. Current, I, is V over R. The voltage is 9 volts. Resistance, R, is 600 ohms. If you divide top and bottom by 3, you get 3 over 200, so it's going to be the same as this. If you don't believe me, put it in your calculator, and you get 0.015 amps. Which again shows that in a series circuit, the current through every component is the same.